Alright, say that once again. So you have section 1, multiple choice, has 50 questions, 1 hour 30 minutes, which is basically 90 minutes for 50 questions. On an average, 1.5 minutes is what, 1.5 to 2 minutes is what you can actually expect to spend. But some questions can be straightforward, you don't have to wait. But some questions can take 2-3 minutes, it's okay to spend some time thinking about it. I have never had students complain about time. It's not like ACT. Right? ACT science, for example, is not something that I will want to do because I like time. I like to really read and digest and then confirm my answers based on a lot of justification, which I won't do in a hurry. So I'm not an ACT person.
I did.
Yes?
Will they have like the equations for centripetal force?
I will show you everything right now.
Okay.
So, yeah, I'll go through everything, don't worry, you won't have anything. Alright, so 50 questions, no talking first of all, because I'm far away, the recording is going on there, and if you're talking, then your volume is going to be much more than mine. It's absolutely useless. Alright, 50 questions, 1.5 hours, and individual questions are single questions where you answer it and then you go on to the next question to the next topic. Whereas question sets are 2 or 3 questions built on the same concept. Multi-select questions are when you have to select 2 answers. 2 of those answers are correct. So for example, if A and C are the 2 correct answers, unless you mark them both, you will not get a single point. There are no negative points. It is just that you should get both of them right. If you got A and B, it is no points. And then comes the free response. The free response is section 2 that has 5 questions and also has 90 minutes. 5 questions for 90 minutes is a lot of time. Okay? So each question is how many minutes? 90 minutes for 5 questions. 18 minutes. 18 minutes for 1 question. So time is ample time, but you have to like utilize the time and make a very good quality answer. And what is this including? This includes 1 experimental design question. Pay attention everywhere. 1 experimental design question. These were not there in the physics B, which we used to do earlier. But now they have included this experimental design question. Is a question that actually will ask you to set up an experiment and find something. But the way they test you is something like this. For example, if they want you to do the spring constant, if they want you to design an experiment for the spring constant, they will say, a student wants to set up an experiment to determine the spring constant, and he can choose from the following list, and then they will give a bunch of components, and they'll ask you to check which ones you will actually pick to perform that experiment. So before you actually do this, you have to plan as to what you want to do, and then when you look at those components, you have to pick on that. Like it will say a weighing scale, a spring, a hanger, a stopwatch, a thermometer, a beaker, water, like what are you going to use for the experiment? You have to keep checking on it. And for checking those things, you get points. Now, suppose you chose the thermometer, which doesn't seem to be, included, connected at all. Suppose you chose a thermometer. It's not completely wrong, unless in your experimental design, you have included thermometer somewhere. Somewhere you have included it and makes sense. Suppose it can make some sense also. Like imagine you are mentioning in the experimental design the spring, a steel spring has different spring constants at different temperatures. As the temperature goes up, the spring constant goes down. And therefore, it is essential that we should mention the temperature of the spring while the experiment was done. And therefore, you take the room temperature and then write it there. So you have included some mention about the thermometer. In that case, when you check the thermometer, that is considered right. You understand that? There's no concrete answer there. So it's like you chose something, and if you have meaningfully explained how you're going to use it, then they'll read it and then they'll give you the points. So it's not like one fixed answer. So that is one experimental design question. Then you have 3 short answer questions, which will be basically testing your concepts of different areas. We have done energy conservation, we have done, projectile motion. We have done so many things. So it will test your concepts through problem solving as well as through explanation, both. And then again, you have one quantitative and qualitative translation, like asking you for the meaning of how that, what that statement means. Like it may sometimes give you, it can sometimes give you a justification given by 2 students. One student A is going to say this, and student B is saying this. Now, what do you think is right about student A? What do you think is wrong about student A and all that? So you're making justifications and all that stuff there. So qualitative translation, quantitative, you may have to use some numbers too. Quantitative means numbers. Qualitative. So overall, number work is going to be less. However, you may use algebraic problem solving. You may use algebraic problem solving. That means what? Without numbers. To give you an example, if if a brick falls from a height h, how fast will it hit the ground? Okay? Now you're not having numbers there. You have letters. So height is given as h. You know gravity is g. And what do? What do? Height is given as h. Gravity is g. And the question is, what is the velocity with which it's going to hit the ground? And what you're going to now do is just use those letters instead of. You can use energy conservation, you can use equations of motion. The final answer is going to be V equal to square root of 2gh. That's your final answer. It's not a number. It's not a number, but it's just an expression. Sometimes they will say express your answers in terms of h and g and other constants. They will sometimes say that. So in that case, you have to express it in that manner. So they will give you some variables, and they'll expect you to use those variables in your final answers. I think you have done some mastering questions like that. Right? You have to express your answers in terms of letters only. So you have some experience of doing that now. Now, what are the different content areas that you need to be absolutely sure of? The first one is kinematics. You have done equations of motion, that's kinematics. And before we did kinematics, we did a lot of foundation, items which are units and all those things, right? Right? And then content area 2 is dynamics, which is basically Newton's laws. So dynamics is all about Newton's first and second and third laws, how it is applied. Circular motion and gravitation is the next one. Energy includes potential, kinetic, elastic, and all those things. Energy conservation. Momentum. It's just only saying one word, momentum, but there's a lot of things hidden in that. Okay? Momentum conservation, rate of change of momentum causing force, and all those things. Collisions, elastic, inelastic, all those things come under momentum. Simple harmonic motion. We have done a lot on simple harmonic motion. Torque and rotational motion. We have done that also. Moment of inertia and all those things. Electrical charge and force. We did that. DC circuits. We just completed that one. Mechanical waves and sound. So you know all about waves and about sound and Doppler effect, all those things. So this is the content area. This is all that's being tested. So as you can see here, 10 main topics, and you have 10 days left. So you can just kind of do them properly divided. Now how does the grading go? This is what they do. Multiple choice, 50% of the final score is put over here, and 50% of the free response is put over here, and then that's your final score. 50% of your final score on multiple choice, 50% of. So, what score are you supposed to get a 5? That's your next one. It is not a 90. So, don't think you should get a 90 to get a 5. Now, when we used to have AP Physics B, the cutoff for the 5 was sometimes 65%, or sometimes 55%, or 60%. That means if you got a 60%, you can walk off with a 5. That was when it was AP Physics B. But now I don't think it is that low. You know, remember AP Physics B was an exam that students took at the end of the senior year, covering material from grade 11 and grade 12. Well, that means, like, imagine all the topics that you're doing for AP Physics 1 and the topics that is supposed to be done in AP Physics 2, all that together tested in one sitting. So, if you can get 60%, it is a 5. I've had so many students walk out of the exam hall and they'll say, I lost so many questions, I couldn't do this. I'm not confident of anything, and they walk out with a 5. But now, it is not as low as that, so don't take it for granted. But, however, I think, in my opinion, 70 to 75-ish is definitely a 5. If you can get 75%, no doubts about it, it is a 5. So to get a 75%, you need to be 75% proficient in multiple choice and free response. If you slightly fall short, then it's a 4. Shorter than that, it's a 3.
Yeah. What do you have to get a 3?
I don't know. Depends, maybe 60%.
Really?
Yeah, I mean, if you get a 60%, that should be a 3 or something like that. Unless you go there and just sleep, only then you can get a 1 or 2 or something like that. I mean, generally, if you do so poorly, that's when actually you get 1 or 2. But with the type of knowledge that you have picked up so far, and if you can put in that extra preparation, you can actually easily get 4s and 5s. Okay? It all depends on you now. My job is over. My job is over. I'm just here to guide you to kind of go in the right direction, and make you think in the right direction. But after that, when you do something, it is purely yours. So if you find some question stuff, just kind of take it out of your head. Don't worry about it. You can go to the next one and next one. Don't just sit over it and say, all right, I lost my 5. No, nothing is over yet. Everything depends on your overall score. So just keep going and do as best as you can. Multiple choice is a place where many students actually end up struggling because they may think something, but the answer is something else. Because it's mostly reasoning, right? Any questions on the format itself? The total time is 3 hours. It comes one after. I don't know if you have a break up. Yes, previously, you know what? Previously, when they used to do AP Physics B, multiple choice, they were not allowed to use calculators. That was an additional problem. They were not supposed to use calculators for AP Physics B, for multiple choice, but free response they could use. But now you could use for all of them. So that is something that's good enough. Let me know if you have questions. All right. That's your kind of worksheet exam. Yes, Miles?
Is there a place to where we could take like example questions that are in the AP like format and like use that to study? or
Multiple
something?
choice, you won't find it anywhere. And even the ones which I'm showing over here, I'm not supposed to put it anywhere.
And then
But free responses, yeah, you can get so many free response questions.
so would you recommend like going in our online textbook and like doing the questions in those like chapters to review or like
I think you'll be better off not that way at all.
okay.
It'll be better off to focus on the pattern of questions.
What do you mean by that?
Like, go to the questions, and if you find it difficult, then go to the corresponding topic and do some extra research. You understand what I'm saying? Like when you do the questions, you find hardship, you find it difficult to understand some of the concepts, then you know that you're kind of shaky there. Then pick that concept and brush it up nicely. Like if you're doing a momentum question and you didn't understand why the answer is chosen that way, although you know a little bit of momentum, you're kind of shaky, that's why you're not able to pick the correct answers. Go and get into the summary of the momentum part and then make sure you understand the whole idea of it. You will see the samples right now. As we do the questions one by one, you should be, in your mind, you should be kind of saying, alright, I know why I thought it's wrong. I know why the answer should be like this. And if you're reasoning it out right, and if you're able to get the answers right, well, that's wonderful. Okay, now, the first thing that they provide you is the data sheet, which is also there on the Rockspace. I put this one on Rockspace so that you know what is provided to you. The table of information. You don't have to keep looking at this one all the time, but you should understand it is there. Okay? For example, when my son was doing the AP Physics exam, he kind of messed up on one question. He chose a wrong formula. He tried to recollect the formula, and then he wrote down the formula, but that was the wrong formula. That was not the formula for that particular thing. The EMF. It's an EMF formula. He should have picked another one. And he didn't think that it was on the formula sheet because he didn't really go through the formula sheet. You understand what I'm saying? So when he had the difficulty of, what is the formula for that one? And he kind of used his memories to get to the formula, but the answer was wrong. And I told him the formula was in the formula sheet. He said, was it there? Okay. It's too late now. The formula is in the formula sheet. But he missed that question because he just didn't realize that the formula is provided to you. Yeah.
Did you get a 5?
He got a 5. So, so you should understand that these numbers and these formulas are available to you, but you don't have to look at that. If you know the formula by heart, why do you want? If you know all the equations of motion by heart, you don't have to look at it. You have to look at it only if you're confused and say, what is that? Is momentum this or this? Confusion? Yeah, then go back. What it says over here is proton mass. Proton mass is given to you. Neutron mass, electron mass, speed of light. You may not use any of this, but it is there for you to take if needed. Electron charge, 1.6 10 power minus 19. You may need it. Coulomb's law, constant. You know the number 9 10 power 9, which is 1 over 4 pi epsilon 1. It's there. The gravitational constant, 6.67 10 power minus 11. They won't provide it to you for each question. You have to know that it is there, provided. Acceleration due to gravity is 9.8 meters per second squared. They won't say it's minus. The minus and all that is something that you have to take. Sign conventions are up on you. They're only telling you the magnitude. Some unit symbols are also provided in case you forgot what is hertz, Hz or anything else. Prefixes. You know the prefixes we did earlier? In case you forgot what is giga, there it is. Centi, micro. In case you have confusions, go back. Trigonometric functions of common angles, they still have it here. Why it was there in the first instance is because they were not allowed calculators before. Before, they were not allowed calculators. So if there was a question of a projectile motion with an angle of 60 degrees or 45 degrees or 30 degrees, there are special angles. So they gave you these special angles so that you can actually not use the calculator but this. Make sense? Now that you're using the calculators, they're still keeping it here, so if anyone wants to still use it. Sometimes your answers are expressed in radical 3s and all that. In that case, this fraction will help you. If you take sine of 60, as root 3 over 2 and then keep that root 3 as it is, you may find one of the options of your answers matching up perfectly. Whereas, if you take sine of 60 as 0.866 instead of root 3 over 2, you may have a fractional answers and you will have some struggle of choosing the answers. And they're giving you here some conventions and assumptions. Assume air resistance is negligible unless otherwise stated. The frame of reference. Positive work is defined as work done on a system. And all that. Or assume all batteries and meters are ideal unless otherwise stated. That means you don't have to assume a resistance or something like that unless they mention it. Like if they give you a cell and only EMF is mentioned there, nothing is mentioned about internal resistance, assume it is not given and not required. Because if internal resistance is required, they will mention it somewhere, either in the question itself. Now coming to the equations, these are the equations of motion. You know it in a different format. You know it as Vf is equal to Vi plus At. Now I don't like writing too many letters, so I don't like this kind of format at all, but it is the same thing. So you can see equation for friction, centripetal acceleration, momentum, force, kinetic energy. So make sure you go through each of these and say, yes, I know where I can use it. Yes, I know where I can use it. If you don't know where these equations are used, that means you're shaky there. And on this side, electricity, they're giving you some equations for electricity. Here is the resistance is equal to resistivity times L over area. And this is Ohm's law. That's power. Delta V is potential difference. Okay, we just called it V. So delta V is the same as just V. And this is the series resistances and parallel resistances. And in waves, they're just giving only one equation, which is a wave equation. And geometry, in case you don't know how to find the area of a rectangle or a triangle or a circle, and volume of this and that and all that. So that is why all those things. All right. All right. Now let's go to the first question. Now over here it says, to simplify calculations, you may use G as 10 in all problems. Because the answers are not going to be so narrowly given. So 10 is okay to use for problem solving. That's why even without a calculator, you should be able to do this. But they're allowing you to use a calculator just in case. Now, it says directions. Each of the questions are incomplete statements below. It's followed by 4 suggested answers for completion. Select the one that is best in each case and then fill in the corresponding circle on your answer sheet. Let's go to the first one. Give it a good start. Can you read it and answer the question? I'll read it for you. In which of the following situations is the kinetic energy of the object decreasing? How many of you think it is A? B, C. There we go. So, obviously, as sphere is dropped from a building, the kinetic energy is supposed to increase. A satellite moving in a circular orbit around the Earth is supposed to stay the same. A baseball is heading upward after being hit, so therefore that is decreasing because it's picking up potential energy. You don't have to even read the next one. Elevator is moving upward at constant velocity. So this is a straightforward question. You don't have to spend any time on this. How many seconds do you think you'll spend on this?
1.
15.
I mean, don't be overconfident on any question. If you find something that is appearing very simple and silly, read it again and make sure there are no catches anywhere. That is something that many students don't do. As soon as they look at a question, they think, oh, I know all about kinetic energy. Okay. And they're in a hurry to get to the answers. And they can be easily a mistake. So, you may get some tough ones right, but some easy ones. So these are some of the questions that most students throughout everywhere, they get it right. This one. But there are questions which actually differentiates clearly from a 5 and a 4 and 3 and all that. Okay, so those are the ones which you should get right. This, I mean, you should try and get right, but these are, you cannot miss it. Alright. 2 protons are held at a distance d apart. So imagine all this. A lot of things you got to imagine right immediately as you read it. And you can even draw it in case. 2 protons are held at a distance d apart. The electrostatic force and the gravitational force that one proton exerts on the other are Fe and Fg, respectively. Which of the following correctly compares the magnitudes and directions of these forces? Which of these correctly compares the magnitudes and directions of these forces? Fe stands for force electric, Fg is the force of gravity. Now, since these are the 4 options here, but there are 2 separate options which you can actually first tackle. You can actually tackle any of these first and then look at the next one. So which force is stronger? Tell me that. Electric is much stronger. Gravity is one of the weakest forces, and you know that. So electrical force is definitely strong force. So Fe is greater than Fg. There are 2 answer choices with that option. So it is either A or B. Then comes the other one. Electrical force between 2 protons and gravitational force. What do you know about the directions? They're opposites. Gravitational force is always attraction. Now in this case the protons are repelling, and so the forces are in opposite directions. So all you have to do is check on A, that's it. Any questions anywhere? Let me know. Here's the next one. A 2 kilogram object traveling at 5 meters per second on a frictionless horizontal surface collides head-on and sticks to a 3 kilogram object initially at rest. Which of the following correctly identifies the change in the total kinetic energy as the resulting speed of the objects after the collision? Now, as soon as you read a certain question, your thoughts must go to that corresponding chapter. And then immediately, as you go to the corresponding chapter, you should start thinking about the concepts of that chapter that you've done very well here. Collides head-on. So you're talking about collisions. What kind of collisions? It's perfectly inelastic. It sticks together, look. Sticks together. Something that is sticking together is perfectly inelastic. Which means there is a loss of kinetic energy. Simple. Now, which answer choice will be your answer? You got to say both kinetic energy and. So I said just now, it is perfectly inelastic. The kinetic energy is definitely going to be lost, so it's going to be decreasing. The kinetic energy, the final kinetic energy is going to be definitely smaller than before because it's lost it. So it's either C or D. Then you have to now look for these numbers. For that, what do? Use momentum conservation. What's the momentum of the first object before impact? 10. What's the momentum of the second object before impact? 0. So what's the total momentum before impact? 10. After impact, the two of them are sticking together to make one mass of what mass? And so what speed it should go in order to have momentum conserved? The answer is C. The answer is C. Next question. I'll give you some time. Let's see if you can get it right. A stone of mass m is thrown upward at an angle of 30 degrees to the horizontal. At the instant the stone reaches the highest point, why is the stone neither gaining nor losing speed? Drew, what's your answer? Drew. Come over here. Who's confident of the answer? Yes, Greg.
I think it's A. It seems like really simple. I think it's A.
Is the acceleration of the stone at that instant 0?
No.
It doesn't matter. I mean, like you think that's. Yes, ma'am. D, because the stone follows a parabolic trajectory and the peak of the trajectory is where the parabola has 0 shape. How many of you think that D is correct? It's like saying Daniel was absent yesterday because he's in the robotics club. Doesn't have to be, no. Maybe he was sick. He was sick probably. You can't actually like connect two things without a problem. I mean, both are right probably. He's in the robotics club and he was absent yesterday, but not necessarily connected. You know what I'm saying? So if you're actually like, I mean, they can ask you something and then, like your answer must be the best answer. And my son says, when he's doing the step exams and all that for his medicine, all answers are correct. And he has to choose the best answer for that. And that is a big challenge. He says, like, it really kills him. Because every time he reads a sentence, that is 100% right. Next one is right. Next one is right. All of them are right, but then which is the best one in the examiner's mind? That should be right. And therefore, it is he says it's pretty tough that way. Now, most of the questions, like over here before, like the first 3 questions that you did outright, only one answer was correct, 100%. The others were rubbish. Whereas this fourth one, if you look at the first one, yeah, that is rubbish. The first one is rubbish because it says acceleration of the stone at that instant 0. You know its acceleration is 9.8. Yeah? So that is definitely not right. But because the net force acting upon the stone at that instant is a magnitude of mg, is that right? That is right.
That's what I
But that's not the answer.
Oh,
That is right, but that's not the answer. What I'm saying is, the net force acting on the stone at that instant definitely is mg. But what is the question asking you? Why is the stone neither gaining nor losing speed? So you got to answer the question. The last one says, because the stone follows a parabolic trajectory, the peak of the trajectory is where the parabola has 0 shape. That is a true statement for any situation. But why is that connected to gaining or losing speed?
it just isn't.
What is that again?
Trick question. It isn't.
So what's the answer?
C.
C is the answer. Now can you tell me why is C the best answer here? That's the other challenge. Why is C the best answer here? So on question number 4, in the real exam, I can expect many to go wrong on this. So this is clearly a question which actually kind of differentiates students.
Because when the forces are equal, then the object is either at rest or moving at a constant velocity.
No, what it says over here in C is because the angle between the stone's velocity and the net force exerted upon the stone is 90 degrees.
Since the force is perpendicular to the velocity.
So force perpendicular to the velocity. So what?
Is either gain or lose.
Why is the moon neither gaining nor losing speed even though the earth is pulling it continuously? Answer that question. Why is the centripetal force, which is a pull by the earth on the moon, not making the moon go faster or slower? Why is the moon not gaining or losing speed? Tell me that answer first. Yes.
Because the moon is kind of moving this way and the pole is pulling it down.
So the force and the displacement are perpendicular to each other. So what is the work done?
Zero.
Haven't you done that concept?
Yeah.
Work done is 0 when the force and the displacement are perpendicular to each other. You have done that, and I think I have asked one of the questions somewhere. The centripetal force does no work. The centripetal force will not be doing any work on an object. Why? Because the centripetal force is always perpendicular to the displacement, and so it won't do any work. So why the moon is moving at a constant speed, even though the earth is continuously pulling it, is because the pull and the displacement are perpendicular to each other. That's the answer. So because the angle between the stone's velocity at the top, that's the top, the stone's velocity at the top, and the weight of the stone is acting straight down. So it's perpendicular. Now what is happening as the stone is climbing? Look, this is the stone that's climbing. Which way is the displacement? That way. Which way is the force? Now, the force and the component of displacement are in opposite directions. So what should happen? What kind of work is that? Negative work. Isn't that the reason why it is slowing down?
Yes.
So when an object is going upward, it is slowing down for a reason, because negative work is being done. And now what if the object is on its way down? Positive work is done, and that's why it's speeding up. So understand the main concepts over there that is covered. It is just question number 5. A small cart is rolling freely on an inclined ramp with a constant acceleration of 0.5 meters per second square in the negative x direction. At time t equal to 0, the cart has a velocity of 2 meters per second in the positive x direction. If the cart never leaves the ramp, which of the following statement correctly describes the motion of the cart at a time t greater than 5 seconds? It's not a number question. See, the answers are not numbers. It's just like. So what is happening at a time greater than 5 seconds is the question. Yes, right?
So the acceleration is positive, and it's still traveling.
Is the acceleration positive?
Let's say 0.5 meters per second.
It is constant acceleration in which direction?
And then negative. Yeah, it's going in the negative direction.
So it's going in the next. So think of a ramp like this. Acceleration is this way, but it's going forward. What's the velocity?
Positive.
The velocity is positive, which means it's going in the positive x direction. So velocity is this way, but acceleration is this way. What will happen to the object?
It'll
It will slow down. Alright, so what do you do now? When it says at a time greater than 5 seconds, take a time of 6 seconds and work it out. Use the equations of motion. Use the equations of motion. What is the initial velocity?
2.
Positive 2, initial velocity. What is the acceleration? Negative 0.5. Acceleration is negative 0.5. Initial velocity is positive 2. Time, take it as 5.5 seconds or 6 seconds, whatever. Anything bigger than 5 seconds. And work it out and find out what's the final velocity. How much is final velocity? Negative. So if I take time as 6 seconds, you get what? Negative 1. So it will be Vf is equal to Vi plus At. That's the formula they're going to use. So Vf is equal to Vi, which is 2 minus 0.5 times 6. So it will be 2 minus 3, which is minus 1. The final velocity is coming minus 1, which means the cart is traveling in the positive direction or negative direction. It is going the negative direction. Now you have to answer these. Is it slowing down or is it speeding up? Speeding up, because now the acceleration is in the same direction as the motion. It's going to speed up. The answer is D. The car is traveling in the negative x direction and is speeding up. So you can see the variety of questions. You may have to, the thought process is completely different in some of these questions.
Six was that.
Alright. Look at that question now. The box is sitting on a ramp. Box of mass m is on a rough inclined plane that is at an angle of theta degrees with the horizontal. A force of magnitude F at an angle of phi with the plane is exerted on the block as shown above. As the block moves up the plane, there is a frictional force between the box and the plane of magnitude F. Which way is the force? Which way is frictional force? Downward. What is the magnitude of the net force acting on the box? What is the magnitude of the net force acting on the box? What is the magnitude of the net force acting on the box? So what are the forces acting on the box? Okay, friction is backward, okay, that's fine.
Gravity.
How much of force F is acting up the incline? How much of this F? How much of this F is this way? F cosine phi. F cosine phi is this way. F sine phi is this way. So how much is this way? F cosine phi. And friction is backward. Is there anything else backward? Is there anything else backward? Okay, what is the gravity part? mg sine theta. You know that. When something is sitting on an incline, the thing that drags it downward is mg sine theta. So what's your answer? C. The answer is C. The answer is F cosine phi minus mg sine theta and minus F, because mg sine theta and F are both opposite directions and F cosine phi is forward. Again, this one, if you know exactly how to split forces into components, it's nothing. This is nothing actually. And again, you're not working numbers. It's easy to work with algebraic terms. With numbers, it will be a little messier here. Alright, here's a question. It's a velocity time graph, and it says an object's velocity v as a function of time is given in the graph above. Which of the following statements is true about the motion of the object? This one you have to go one by one and rule it right or wrong. So let's go to option A. The object is not moving from t equal to 4 seconds to t equal to 10 seconds. Is that correct? No. Yeah. So from 4 seconds to 10 seconds, it is a straight line horizontal, which means constant velocity, so this is not right. A is not right. B, the object's initial and final positions are same. What decides that part of it? Object's initial and final positions are same implies no, displacement is 0. Is that displacement 0? How do you know this? Area. Now, if I can find the area of this and area of this, if the total area comes out 0, in other words, if this area is equal to this area, then this answer should be right.
Yeah, they both have the same area.
You already did it? Now,
Yeah, I can look at it and be like,
okay, doing the area may take some time, but let's go to the next options. Let's go to the next options. The object is slowing down from 14 seconds to 16 seconds. From 14 seconds to 16 seconds. Between here and here, the object is slowing down. No. So C is out. The average acceleration of the object from 0 to 4, from here to here, this acceleration is different from the acceleration from 34 to 36. 34 to 36. This acceleration is different from this. Is that true? That's also wrong. So obviously the answer is B. So you don't have to even do the work for area, and you can conclude on that answer. Or just find the work, find the area. Half B1 plus B2 times height. Half B1 plus B2 times height. And you'll get the area. And you can find the areas are basically the same. So that means that it is now here's a typical question where the answers are in sets. You know, I told you there are sets. Look at this question saying, questions 9 and 10 refer to the following material. Oh, by the way, you missed something. Did you read this?
Yeah.
Item 6 was not scored. So they have not put 6 over there, it's blank. Why item 6 was not scored is because when the paper setter set the paper, there must have been some kind of vagueness in the question, which made it difficult for students to answer that question because it could be this, it could be that. So, question was considered wrong. And therefore, what happens after the exam is over, when the examiners kind of go through the questions, and the people who are checking the papers, they get together, before they actually disperse the papers, they'll get together and they'll be going question by question and checking what answer is appropriate, whether how much to give it and all that stuff. When that is being discussed, many people come to the conclusion that okay, item 6 is absolutely rubbish, it cannot stay in that paper because it is not the right thing. Students can get really confused with that question and it is not right to confuse the students, therefore knock it off. So sometimes they'll knock off 2 or 3 questions this way because the one who sent the paper obviously must have missed out 1 or 2 words from the question, which made it difficult for students to understand. So when they knock off questions, of course, obviously you don't have 50 questions, it will be lesser, like only 47 questions, but then they actually multiplied by a factor to make it 50. You understand? They'll multiply it by to make 47 to 50, they multiply by that conversion factor, and they bring the score to 50. All right. All right, here we go. The first one, in the circuit shown above, the sum of resistances R1 and R2 is 8 ohms. What is the current through the battery is the first question. They gave you this. They're asking you the current here. Tell me the answer and tell me why you made this decision. The sum of R1 and R2 is 8 ohms. The sum of R1 and R2 is 8 ohms. Anyone has the answer? Yeah. B, 5 amperes. Why? Voltage for parallel resistors are same, correct? So 2 times 4 is 8 volts. And that means it should be 8 volts over here. And the total resistance is 8. So the current here should be 1. If the current is 4 here and 1 here, the current here should be 5. So this is how you do it. And now we can see how we touched up the Kirchhoff's first law. And some of the concepts of parallel resistors. So you have done the concepts, got applied. Next one. Resistor R1 and the 2 ohms are now swapped. Like this comes here and this goes there. How does the current in the right branch of the circuit change and why? The current that was here was 1 ampere before. Now, how is it going to change and why? If you swap R1 in the place of 2 and 2 to that place, how is the current in the right branch changing and why? Yes, ma'am.
D.
Answer is? Why?
Because you don't know if it could be 7 ohms or like 1 ohm.
Exactly. It is D, because you don't know if it was a 1 and a 7 or a 7 and a 1, because when you swap it, the total resistance here could be changed, and so the current over here is totally something that depends on the resistance values of R1 and R2 individually. We'll continue with this.